Another skill that's really important for a chemist who making medicine. Okay, when you make a medicine, let's say in this case we want to make an S-naproxen, which is pain relief, fever relief medicine, and R-naproxen kills your liver. Right? Of course, we want to make just an S, not an R. But here's how we do it. Let's say we do some synthesis. We get a solution at the end of the experiment. All right, and we use the polarimeter to measure the observed rotation. And it comes out at plus 59.4 degrees. What does this tell you? First of all, this is not pure, which is usually happen, right? Not all the synthesis you always get the byproduct or something else, right? Which is not pure. And you might be able to guess too. Well, this number is close to S-naproxen plus 66 degrees, you know? And because it is were to be R, it should be negative. Yes, it's closer to S-naproxen, so we have more S than R isomers. But how much more though? We need to know how much more of S than the R. When we want to sell this, we don't want any R actually, right? That's like the ideal. But we have the mixture. We should know how much S we get S more than R, right? And to do that, we have another a new term for you. We call percent enantiomeric excess to indicate how much more one isomer than the other. Okay, and here's how it works. Let's say if I have a pure S, enantiomerically pure S, and the observed rotation is plus 66 degrees, and a pure R is negative, not positive, negative 66 degrees. Okay, and if I have a mixture, 50% S, 50% R, what's the observed rotation? You can guess that's a racemic mixture. They cancel each other out, going to be zero, optically inactive. They don't rotate the plane of polarized light. Okay. Now, if I have only 25% R, 75% S, what's the observed rotation? Let's do this. How much more S than R? How much more? 50%. That's the term we're going to use. Right now, this solution is 50% enantiomeric excess for S isomer, okay? Which means that they have S more than R by 50%. What's the S? What's the total S? 75% S and only 25% R. 50% S doesn't mean 50 S, 50 R. This is 75 S, 25 R. If you don't get what I mentioned, I talk about this. Let's get into the detail real quick. Let's make sure you understand this, okay? Oh, by the way, so the observed rotation of this solution is plus 33 degrees, closer to S than R, okay, not negative. Anyway, 50% excess S means that there are 50% racemic mixture, and the other 50% that's an S isomer, okay? So 50% S, one more time, 50% enantiomeric excess of S isomer mean that they are 50% pure S, and the other 50% is a mixture, right? Racemic mixture between S and R equally. So how many S total? 75. So we have 50 plus 25. That's 75 S and 25% R. Okay, and the observed rotation is plus 33 degrees. All right. So here the scenario going to be right here. Do some synthesis. All right, and you get the final solution. Measure the observed rotation it goes plus 33 degrees. Right. If it were to be pure S, it's supposed to be 66. If it were to be a pure R, it's supposed to be negative 66. This is somewhere in between. So how much S than R or R than S we can calculate using this formula, right? Percent EE equal to observed rotation is right here. Plug in there. And over the specific rotation of pure enantiomer down here, plus 66 and times 100. I'm not gonna take negative 66 because this number is closer to S, which means they are more S than R. So we're gonna use the plus 66. That's for an S isomers. Okay. So do calculation. Is it 0.5? Right here. This term is 0.5 times 100, 50% exactly. Okay. All right. What does 50% EE of S isomer means again? S is excess R isomer by 50%, so they are 50% pure S, right? And the other 50% is a mixture between S and R. That's the meaning of 50% enantiomeric excess. Okay, 50% EE of S doesn't mean that they are 50% S, 50% R. This is 50 of pure S, and the other 50 is a mixture. All right. So how much S isomer are there total? So 75% and 25% R. That's the meaning of it. Okay. Don't get it confused. All right. So let's say if you see this on the quiz. Okay. So the specific rotation of S isomer is plus 66. A chemist try to synthesize S naproxen, and the observed rotation found to be plus 59.4 degrees. Calculate percent EE of the product and percent of the S isomer in the solution. Okay. All right. Let's start with the percent EE first, and we can talk about the try to explain percent EE to a simpler version of it. Okay. All right. Calculate percent EE of S isomer. So there are more S than R anyway. So the observed rotation closer to the S isomer. So we're gonna plug in 59.4 degrees, and observed rotation of pure enantiomer. This one is pure S. Take S. 59.4 divided by 66 times 100. You should get 90% EE. Okay, so we get 90% EE. How many S do we have total? 95% S. Right? 90% EE means that these are pure S. Right? S is pure by 90%. And the other 10% is a racemic mixture between S and R. So we have 90S here plus 5S in here in the racemic mixture. So 95S and 5% and R. Oh, right there. Okay. All right, that's how it works. Let's move further.